Welcome back to the deep dive. Okay, what if AI could really understand what you actually mean? Not just the exact words you type.
Right, getting beyond just keywords.
Exactly. Today, we're diving deep into the tech that's making that happen. We're looking at the engine behind the latest AI agents and smart apps.
It's fundamental stuff.
It really is, because the intelligence in these systems, it's not just about what they already know,
Yeah.
right? It's how they access and understand, like, new information instantly, relevant information.
And that's the tricky part. Because without good retrieval, accurate retrieval from all that data.
You get those AI hallucinations.
Precisely. Confident but wrong answers, which nobody wants.
So the solution, or a core part of it, is this thing called vector search.
hmm
And it's not like old school search, no keyword matching. It uses these numerical embeddings.
That's the key concept. Think of an embedding as like a numerical fingerprint for information. Text, images, whatever.
A fingerprint that captures meaning.
Exactly, meaning context. It lets computers see relationships that keywords just completely miss. Vector search compares these fingerprints, these embeddings, to find things that are semantically similar. It gets the intent.
Okay. And today, we're zeroing in on Vertex AI Vector Search 2.0 from Google Cloud.
Yep, the latest generation.
And you're saying this is built on the same tech that powers, like, Google Search itself and YouTube.
That's the pedigree, yeah. Battle-tested infrastructure, huge scale, low latency. That's what they're bringing to developers now.
So our mission today, for you listening, is to unpack why this vector search tech is so essential now in this AI world and how this specific service works.
That makes sense.
Okay, so let's start there. How does vector search actually solve problems that, the old ways couldn't?
Well, it's a great question because the old ways think classic search engines, basic SQL queries, they hit a wall pretty fast with AI needs.
Well, so
They're all about exact keyword matches. So they struggle with synonyms, they totally miss the context sometimes, and they definitely don't get, like, subtle user intent.
can you give an example?
Sure, let's say you've got an internal chatbot for Acme Corp. A user asks, what steps does Acme Corp take to be carbon neutral?
Okay.
A keyword search might find nothing if all the documents talk about net zero plans. The words carbon neutral aren't there, so PFFT, nothing.
Ah, right.
But vector search, using those embeddings we talked about, it understands the meaning. It knows carbon neutral and net zero are, conceptually very similar. So it finds the right documents, even with different words.
And that understanding, that semantic link, that's what helps avoid the AI making stuff up.
Absolute crucial. It's how AI agents get the right information. It avoids those hallucinations.
Yeah.
And there's this related idea of grounding generative AI.
Grounding, like keeping it connected to reality.
Exactly. Tying those powerful creative models to actual facts, your company's data, up-to-date information. Vertex Vector Search does this. It indexes your data as embeddings and then pulls out the relevant bits instantly when the AI needs context.
So it grounds the AI's answers in your organization's truth.
Perfectly put. And the quality of that grounding, well, it totally depends on how good the search results are. Better search literally makes better AI. It's not a nice to have, it's a necessity now.
What's fascinating here is how much of a leap this is, and Vertex AI Vector Search 2.0 is right at the heart of it.
It really is paving the way.
So you mentioned it's the next generation, fully managed from Google Cloud, an evolution from the old matching engine. What's specifically new or improved in this 2.0 version? What makes it stand out?
Right, so 2.0 brings some really significant improvements, especially for developers. First off, there's a much more intuitive SDK and developer experience.
Easier to use.
Much easier. They focused on making it super simple to get going. You use the standard Vertex AI SDK for Python, and literally, like, a few lines of code can create and query an index. No messing with low-level APIs or managing infrastructure bits.
Okay, that's appealing. What else?
Then there's the serverless, fully managed architecture. This is huge.
Meaning no servers to manage.
None. Yeah. You don't provision anything. You don't scale anything manually. Google Cloud handles all the replication, high availability, scaling up or down. It just works.
Yeah.
And it's pay as you go.
So cost effective too.
Very. You only pay for what you actually use. It makes this kind of powerful tech accessible even for smaller teams, not just giant corporations.
That serverless part leads to faster setup, I imagine.
Exactly. Which brings us to faster onboarding from zero to query in minutes. It's incredibly streamlined.
Minutes, really?
Yeah, Google has these quick start notebooks. They show you setting up an index in like under 30 minutes. You just upload your embeddings, your data, fingerprints to cloud storage.
And the complex stuff, like building the search index itself.
All handled automatically. Things like building the approximate nearest neighbor or ANN indices. That's all done for you.
ANN, what's that, quickly?
Right. ANN indices are basically clever data structures. They let you search for close enough matches super fast in massive data sets, billions of items. It's not perfectly exact, but the speed gain is massive, essential for real-time AI. And the point is, the developer doesn't even need to think about it here.
Okay, so it abstracts away that complexity.
Totally. You upload data, create the index via the SDK, and you can be querying it literally minutes later.
Wow. And integration. Does it play nice with other AI tools?
Yes, it's the final big piece. Seamless integration with the AI ecosystem. It's designed to fit right in.
Like with LangChain.
Yep, LangChain has official support now. You can use Vertex AI Vector Search directly as a vector store in LangChain. It also integrates smoothly with Llama Index and, of course, Google's own Vertex AI ARG engine.
RAG being retrieval augmented generation.
Exactly. So less custom code needed to glue things together,
Right.
fits into MLOps workflows, uses Vertex AI security, identity management, logging. All that enterprise-grade stuff is built in.
That integration and the ease of use, that's really compelling. But the big question for anything enterprise, scale, how does it actually deliver Google-level scale without making developers into, distributed systems wizards?
Right, because scale without complexity is the dream. And it delivers because, well, it is built on that Google scale infrastructure. The same stuff powering search and YouTube.
So it can handle massive data sets, billions of vectors.
Billions, yeah. Without the latency going through the roof, we're seeing big names using this already, like eBay and Mercado Libre.
For recommendations and search?
Exactly. They're seeing real benefits, faster search, better user engagement. Bloomreach is another one using it for advanced semantic search. It really does handle huge data fast.
And for the developer, they don't see that underlying complexity, no manual sharding or clustering.
Nope. Vertex handles partitioning the data, spreading it across the hardware. It automatically scales up the replicas if you get more queries per second. It adds shards if your data set grows. It just feels like one service that scales itself and heals itself. No manual tweaking needed.
Okay, could you walk us through what that developer onboarding looks like step by step, briefly?
Sure, it's pretty straightforward. First, prepare your data. That just means getting your embeddings. You might use a model like Google's text embedding Gecko that gives you, say, 768 numbers for each piece of text.
768 dimensions, right. That's the fingerprint length.
Exactly. More dimensions, potentially more nuance, but more compute. Second, you upload those embeddings, usually as simple JSON or CSV files, into Google Cloud Storage. Easy enough.
Okay.
Third, you create the index. Using the SDK, there's a specific function call. You tell it the vector dimensions, like 768, the distance measure like cosine for meaning, or maybe Euclidean distance.
Different ways to measure similarity.
Right. And you set the approximate neighbors count that balances speed versus accuracy, and you point it to your data in cloud storage.
Got it.
Fourth, once it's built, you deploy the index by creating what's called an index endpoint. This makes it ready for queries. You can make it public if needed.
And finally,
You query the index. You send it a new embedding, say, for a user's search query, and ask it to find neighbors. It shoots back the most similar items from your index super fast, like tens of milliseconds fast.
query indexes in minutes with just a few lines of code. That was the promise.
That's pretty much it. And like we said, this slots right into things like LangChain. Use Vertex AI embeddings to make the vectors. Vertex AI Vector Search to talk to the index. An agent can just use it as a search documents tool. Seamless.
So that internal Q&A bot example.
Yeah, think about it. Split docs, get embeddings, push to the index. User asks a question, the bot vectorizes it, queries the index for relevant bits, feeds those to an LLM.
And the LLM gives an answer based on the retrieved facts.
Exactly. A grounded answer.
Yeah.
Maybe takes a second, end to end.
Yeah.
Reduces hallucination.
Mm-hmm.
Allows citations back to the source docs. It lowers the barrier so much for companies to build these really smart, reliable AI features.
That is a huge step forward for developers. But what's really fascinating is how much more it can do. It's not just finding similar stuff, is it?
No, not at all.
Like you mentioned hybrid search, it's in preview, but it combines semantic search with old school keyword search. Why? Why would you need both? Isn't semantic the goal?
It's a great point. Because often how people search or what they need, it's a mix. It's rarely purely semantic or purely literal keyword matching.
Give me an example.
Okay, think about shopping. Someone might search for shoes for a summer wedding. That needs semantic understanding, right?
Right.
What kind of shoes fit that
Well,
vibe?
right, context.
But then they might add brand, Nike. That's a specific literal keyword filter. Hybrid search handles both gracefully in one go.
How does it actually work then, indexing both kinds?
Pretty much. Vertex can index both the dense embeddings, for the semantic meaning, and sparse embeddings, which are more about keyword frequency, like TF-IDF or BM25 scores.
TF-IDF, BM25, those are the classic keyword scoring methods.
Yeah, they focus on word counts and rarity. So a single query comes in, the system scores documents based on both semantic relevance and keyword matches, and then intelligently merges the results.
That sounds really useful for AI agents, like searching logs.
Exactly. An agent looking for an error code needs that exact string match, but also wants the semantic context around why that error happened. Or customer support needs a specific product name, literal, plus the user's fuzzy description of the problem, semantic.
And Vertex handles this blend in one API call.
Yeah, that's the beauty. No need to run two separate search systems and try to merge the results yourself, which can get complicated fast. Hybrid search gets closer to how humans actually think and ask questions.
And this isn't just text, right? You mentioned multimodal.
Absolutely. Embedding is just a list of numbers. It doesn't care if it came from text, an image, audio, whatever. So yeah, fully multimodal.
So I could search for images similar to another image?
Easily.
Mm.
Or even cross-modal search. Find an image based on a text description, or vice versa. Google has powerful multimodal embedding models for this.
I think I saw a demo. Searching for chairs similar to a picture.
Yeah, things like that. Or even mixing modes in a query, like find items that look like this image but make them red. That kind of thing is becoming possible.
Okay, what other advanced features are there?
Another big one is real-time streaming updates, sometimes called streaming ingestion.
Meaning you can update the index on the fly.
Exactly. Insert new items, update existing ones, delete them, and have those changes reflected in search results almost immediately. Super important for dynamic stuff.
Like product recommendations, if new products are added constantly.
Perfect example. Or monitoring systems. Maybe real-time fraud detection. Mercari, the marketplace. They use this so new listings pop up in similar item searches right away. It enables that real-time feel.
Makes sense. And filtering, can you narrow down semantic searches?
Oh yeah, filtering is crucial for enterprise use. When you index your items, your documents, products, whatever, you can add metadata, like tags, categories, user IDs, security levels.
So at search time.
At search time, you can do the semantic similarity search plus apply filters. Find similar documents where categories legal AD access level is public, Absolutely essential for things like multi-tenant apps or just respecting data permissions.
And underlying all this, the usual enterprise concerns, security, compliance.
Right, and being part of Google Cloud, it inherits all that good stuff. Encryption, identity and access management, IAM for fine-grained control, audit logs, private network connections. All the table stakes for serious enterprise adoption are there.
Okay, so connecting all these features, all these capabilities, how does this translate into the actual AI applications people can build? What does Vertex Vector Search 2.0 unlock?
That's the payoff, right?
Yeah.
What can you do with it? And the answer is, well, a lot of really impactful things.
Like the Q&A agents we mentioned.
Definitely. It's the foundation for knowledge retrieval for QA agents. Customer support bots, internal HR bots, research assistants. They can use the vector index to find relevant, factual snippets from your knowledge base.
Grounding their answers.
Precisely. Reduces hallucination, makes responses evidence-based. They can even cite the source documents. And with LangChain integration, it's like giving the agent a superpower tool.
Okay, what else?
It's the retrieval engine for retrieval augmented generation, RAG, systems. This is huge for generative AI.
Explain R8 again quickly.
Sure. Instead of relying only on the LLM's pre-trained knowledge, you first retrieve relevant, up-to-date information from your own data using vector search, and then feed that context to the LLM to generate its response or summary.
Like summarizing massive reports.
Exactly. Chunk the report, index it, retrieve the key parts for a specific question, let the LLM summarize those. Much more scalable and accurate. Vector search is the memory that feeds the LLM real-time context. Google even has the Vertex AI RAG engine service to help orchestrate this.
Makes sense. What about user-facing apps?
Big impact there, too. Powering advanced search and recommendation in applications. Think e-commerce. Semantic search, understanding natural language, some addresses that are light and flowy, or even searching by uploading a photo.
Improves engagement, presumably.
Hugely. And recommendation systems, which are basically just ongoing searches for items similar to what you liked, become much more relevant in real time. We mentioned eBay using it effectively for this.
Interesting. Any more examples?
Yeah, a couple more. Monitoring and anomaly detection. You can embed system logs or time series data into vectors. When something weird happens, you search the index for similar past events.
So this weird spike looks like that outage we had 3 months ago.
It's exactly. Helps AI ops systems diagnose issues faster, predict problems. The scale of Vertex makes this feasible for massive amounts of monitoring data.
And finally,
Enterprise search and knowledge management. Basically building your own internal Google for all your company's documents, wikis, databases, emails.
an organizational brain.
That's a good way to put it. Combining that deep semantic search finding meaning with the filtering needed for security and permissions. So people find what they need and only what they're allowed to see. All these applications, they really build on the same core strengths. The speed, the scale, the accuracy, and that easy integration. Developers get to focus on the cool application logic, not the heavy lifting underneath.
So yeah, Vertex AI Vector Search 2.0, it really does feel like more than just a tool. It's like a strategic piece for building genuinely intelligent systems.
It enables a new class of applications.
It's clear that AI agents, RAG systems, they're not stuck with just their training data anymore. They can actively pull in and reason over huge amounts of external info in real time. And vector search is the key. Okay, let's maybe recap the key takeaways for everyone listening. What makes this stand out? First, unmatched scale and speed. Built on Google's search DNA, handles billions of items, millisecond queries, high accuracy.
Check, the performance is definitely there.
Second, ease of use. Those intuitive SDKs mean you can get going in minutes, not days or weeks.
Big win for developers, for sure.
Third, fully managed and serverless. It's scaled automatically, you pay for use, opens it up for teams of all sizes.
Takes away a lot of operational pain.
Fourth, rich capabilities. We talked about hybrid search, real-time updates, filtering, multimodal. It's very flexible.
Covers a lot of advanced use cases.
Fifth, seamless integration. Hits right into the Vertex AI ecosystem, works with LangChain, R-Engine, standard MLOps tools.
Makes it practical to deploy.
And finally, that enterprise trust. Security, compliance, and it's proven in production by major companies.
Essential for real-world adoption.
You know, if people say AI is the new electricity, then maybe Vector Search is like the power grid. It's delivering the data current that actually energizes these AI agents.
I like that analogy. It gives them the knowledge, the context they need to be truly useful.
Yeah, it transforms them from just responding to actually like understanding and helping. We really hope you explore what Vertex AI Vector Search 2.0 could do for your own projects.
Absolutely. And maybe a final thought on that. Vector storage and search, they really are the backbone now for organizing all that rich semantic information that you need to ground these powerful generative AI models, their ability to handle all sorts of data, power really meaningful search, and do it efficiently at scale. Well, it makes them the ideal engine for this next wave of AI innovation. So the question really is for you, the listener. How might you use these semantic superpowers to build systems that truly understand and serve your users in ways we couldn't even imagine just a short while ago?